Hello and welcome to the new episode of AZ DevOps with Pamir and Mert. And today we will continue our previous session, scaling on Kubernetes with Prometheus and KEDA. We had some general live demo problems, but today hopefully everything will be fine.
No, it will
Pamir,
not be fine. Of course, they will
okay,
fail.
okay. Pamir, welcome. How are you?
Thank you. I'm fine. That's it. So let's begin.
Okay.
Thank you. Let me close my webcam. So last week we talked about the Prometheus and Prometheus, how to scale the pods and our workloads with Prometheus and Prometheus adapter. And today we will talk about how we can scale with KEDA. So the thing is very basic, why we are talking about KEDA. And let me open my whiteboards with you. Just a second. So the thing is, beautiful. Yes, that's perfect. So the thing is, I want to scale my pods reactively. What does that mean? The thing is, if I have talking about serverless architecture, we should talk about the events. And what is an event? Why it matters in a serverless architecture? The thing is, I have an event in here. An event occurred in an environment. And I should react depending on that event. For example, I put an image to a storage. Maybe there's an HTTP trigger, or maybe I put data, insert some data on Redis, or maybe I just it should be an employee company acquisition. It doesn't matter. It's just an event. So what matters is, for the service architecture or event-based architecture, depending on that event, I should react. How can I react to that event? I will, of course, first of all, understand what the data is, what the event is. And depending on that, I should process the data as a function. Let's say that fx. And depending on that event, after processing the event, I should write data to another place. Like if it's an HTTP, I can return the answer. Maybe it's an image, I can put the image after processing the image to another storage, or I can make an OCR process on that image, and then I can insert the data on the database. But the matter is, it is an event in here. So we talked about last week, and let's say that CPU and memory, and the memory, let's call it memory. These metrics are not important in terms of scaling. They are, let's say that they are not too correct to scale based on CPU and memory. The reason is, it's the end result of something. It's the end result of processing the data, processing the event. So I start to process the data and the CPU increases, and depending on CPU consumption, I scale my pods. This is the end result of processing the data. Maybe depending on the image size, my memory consumption is increased, and then depending on the memory utilization, I may scale my pods or the VMs depending on the memory consumption. But the thing is, if my source code is efficient enough, how can I scale my application based on CPU and memory? They become useless. So the thing is, depending on the result, instead of depending on the result, I should scale my pods depending on the event. What does it mean? If an HTTP request kicks in to my pod or my load balancer, I want to scale my pods. Or let's say that I put some data on my Kafka servers, or I put some let's say that put some data on service bus, or pops up, GCP pops up, or I insert some data on a database, a Redis server. Depending on the data, something should watch the data source, and depending on the data source, it should scale my pods. That is a perfect approach for event-based architecture in terms of scaling. So Kera is for that. So if you have an event-based architecture, or if you have pods on Kubernetes, we can forget about the CPU and the memory. What we should care about is what is our data source and how can we scale it. So basically, Kera watches the data source, and then depending on your data and depending on your scaled object, it scales your deployment. So let me show how can we scale. Let's go to Kera, Kubernetes web page, and let's discuss what Kera is. So first of all, I kicked into the page, Kera page, and I opened the scalers. What I have in Kera's web page, there are numerous data sources that I can use to scale my pods or scale my architecture. For example, depending on ActiveMQ or Apache Kafka or Azure Log Analytics or Azure Monitor, there are a couple of some scalers that I can watch and scale. So the thing is, let's say that I have an event bus and some data, some pods are generating data on event bus, and depending on the event bus, I want to scale my pods. How can I do that? The thing is, first of all, what I need is a KEDA operator for that, like Kubernetes metric server, because it needs something to watch the other data sources. And after watching the data source, regarding to your horizontal pod autoscaler, I mean, it's not in the KEDA, it's not a horizontal pod autoscaler, it's a scaled object. Based on your decisions, it should scale your deployments. So first of all, what should I do is deploying the Kera. So how can I install Kera on Kubernetes? Kera install, let's search Kera install. If I go to this page, it says that, first of all, I should add the repository of Kera, and after that, I should install it. So the thing is, if I do that way, I cannot customize the Kera. What I have to do is, I should go to the GitHub repository, and after that, I should look the values.yaml file, and depending on the values.yaml file, I should deploy my KEDA operator. KEDA and GitHub. That is the correct way. I mean, for me, that is the correct way to install KEDA. Let's say that values.yaml file. That is the one. First of all, we should look at it. So the thing is, if you install KEDA from here, the tag is empty. So what does it mean? Pull policy always. It will always update your, if and restart occurs, in the KEDA operator, I mean KEDA metrics API server, it will repull the image, and then sometime later your KEDA operator can be upgraded. So we don't want it. First of all, we should download it and understand the hash sum or the version of that, and after that we should install the KEDA operator for it. That is very important while installing the KEDA operator, because if you don't set the tags in here, your KEDA operator always will be upgraded after the restarts or another releases happens. Host network is use host network. It's necessary for Nginx post, but it's not necessary for here. Metrics adapter, RBAC, of course, it should be enabled. Service account, it should be enabled. And for the logging operator, you can set to debug in here. Format, you can set it to JSON or console in here. It should be cluster API for us. It doesn't matter how we can open it. So the thing is resources. If I don't set the correct CPU and memory request in here, the operator will be restarted again. And of course, no selector and the affinity. So the thing is, what is important is for ourselves while deploying, the first thing is we should care about the tag number. We should care about resources, limits and requests in here. And we can enable metric server in here. I mean, we can enable Prometheus service motor objects in here, and then Prometheus can grab the metrics from here. So what I'm going to do is, I'm changing my default namespace to Kera. So list. Let me list if I installed Kera for that. So uninstall. Let me uninstall Kera, and after that we can upgrade install Kera. So what I need is, so let's go to my Helm charts, tools data, ls, cd, and charts should be in here. Get a charts, git remote -y, yes, git pull. I will pull everything in here. Okay, everything is updated. Everything is up to date. So first of all, what I should do is I should install Kera. So kubectl, sorry, instead of kubectl, helm repo list. I should add this custom repository on my repository list. So I added before. Let me execute these codes. It doesn't matter if it's added or not, but let me do step by step. And one. Okay. So it's for, I don't need to do that, but let's do it. So it's for Helm2. Be careful about that. We will install by using Helm3 because Helm2 is not supported right now. And I will not set the exact version of the Helm charts. Let me fix this code. That one. I will skip version number. Namespace Kera is perfect. Kera is okay. -f values.yaml file is perfect for us. And let's install it. Kera charts ls. So it should be in here. Yes, values.yaml file. I have the values.yaml file, and let's install it. Okay, cool. So the Kera is installed. First of all, we should check it if it's installed or not. Okay, It's not ready. We should wait all the pods to be ready. Let's wait for 5 seconds to 30 seconds. It will be ready in 30 seconds. Okay, as I guessed, in 30 seconds, it's ready. So the thing is, what should I need to deploy and scale my application? First of all, of course, what I need is an application. So yes, that one. There's a perfect explanation in here for scaling the pods depending on service bus queue. So let's look at the KEDA core sample.net. I mean, this sample. It basically says that for the KEDA operator to scale your pods, you can use Azure AD pod identity, or you can use connection string for authentication. So what should I do is, I have an application, and depending on the application, I mean, depending on the Azure service bus, I want to scale my pod. How can I do that? I can do it in Prometheus way if I grab the metrics from Azure service bus. So depending on the, again, the Prometheus metrics, I can do that. But there's an easy way to do that. If you compare the previous week, it is a Kera. So basically Kera has these scalar objects, I mean scalars. So I have service bus directly integration. I don't need to grab the metrics from Azure Monitor to Prometheus, and then after that, depending on the custom metrics or external metrics, I'm making some complex Prometheus queries. Instead of that, I will use service bus scalar in the Kera object. So basically, it says that if you want to scale your application, depending on the service bus queue size, message count, you should add your scaled object to these metrics. I mean, these parameters. What is the topic name? How can I connect the service bus? It's a base 64 connection string, and average message queue size, message count per pod. So it basically says that concurrently, I mean, the average message queue size should be 5 for each pod. So if I have, for example, 9 message in the queue, I will have 2 pods. If I have 14, I will have 3 pods. So let's do the example. So what I will do is, first of all, let me create another namespace, Kubernetes. If I have any temporary namespace for me, I will switch to that namespace. Write the same code again. Okay, okay, that is perfect. Kubernetes, easy scaling, CTL, get pods, CTL, get pods -a. First of all, I will look at the Prometheus demo. Okay, it's okay. Everything seems okay. Kera operator. Okay. So easy scaling is perfect. The thing is, what should I do is, I need an application. Let's deploy that YAML file. Let's get it. So let me open my Visual Code and let's get the deployment YAML file. The thing is, basically it's an ordinary deployment YAML. And the thing is, it grabs the, consumes the message from service bus and it processes the data. But what if my CPU and what if my memory is not utilized enough? I cannot scale. My question is, I want to scale depending on the service bus. So first of all, I should deploy it. Is there a namespace in here? No, I don't have any namespace. Okay, perfect. So k apply -f deploy.yaml file, kgpo, again kgpo, watch kgpo. Let's wait. Okay, kb svc. Okay. Sometime later, in 10 seconds, it will get an IP address. Okay, the IP address is gathered. My question is, I want to scale to 0, 0 to 1, 1 to 2. Kera is perfect for that. So let's go to connection string and what we have. Cat deploy auto scaling YAML file. So the thing is, let's look at that one. There are three very important objects in here. One is trigger authentication. The other one is ordinary secret. The other one is scaled object instead of horizontal pod scaler. So the thing is, let's look at the secret. It basically is the secret that holds the service bus connection string. Where does it come from? I have a service bus in Azure. So let's go to Azure portal and service bus in here. KEDA bus in here. I have queues in here, and I created a queue in here named order bus. An order bus has a shared policy in here, and I have the primary connection string in here. So what I have done is I just copied the endpoint in here and go to base 64encode.org. We encoded the connection string in here. So after encoding operation, we just put the connection string in the secret. It's just an ordinary secret for Kubernetes. The thing is, the name of the service bus connection string is very important. So depending on that name, I'm coupling with trigger authentication. So in the secret, I have the connection string. In the trigger authentication, we are setting the connection script name in here. These are the same. This authentication metadata, the authentication trigger authentication data is coupled with the secret, and the name of the secret is secrets order management, and the key of the connection string is service bus order management connection string. So these are very important. This coupling is very important. So I have the trigger authentication. I have the secret right now. So I need third object, which is named scaled object. So basically, a scaled object is how should I scale my objects? So I'm replacing, I mean, in terms of, it's a conceptual replacing. I'm, instead of writing a horizontal portal scalar, basically saying that I will use scaled object. It's just the name, and this is the scale target ref. Scale target ref is order processor, which means that what is the name of the deployment? It is order processor. So maximum replica count is, of course, is the pod maximum pod size, pod count. So what is the trigger for Kera? It is Azure Service Bus. It says that depending on service bus, I will scale this order processor. So what is the name of the object? What is the name of the queue? It's order bus. It is coming from the Azure Service Bus topic name. So the thing is message count. So what is the average queue size per pod? The other one is authentication ref. Authentication reference is the trigger authentication. So this time I am coupling the trigger scaled object with trigger authentication. So while I'm connecting to other data sources, I need a trigger authentication object. So what is a scale object? It's something like horizontal pod autoscaler. I mean, it's just something like horizontal pod autoscaler. I have three important objects in here: the deployment name, the data source for Kera to watch, and the authentication for connecting to data source. So KGPO on the rep, not that one. Let me delete this pod. KRM dep order rep s. Let me deploy this application, deploy app. So deploy app, this one. Okay, perfect. So this time I will, this is my exact deployment because this is the order deployment, order processor. So depending on order processor, I will scale the objects. So k apply -f deploy app. Okay. Are there any namespaces in here? No, I don't have. Okay, cool. KGPO. So let's apply -f. What I have is deploy auto scaling. First, no matches for kind scaled object. Perfect. Another problem in here. Unable to recognize deploy auto scaling Yaml. It should work. Perfect. Another problem. Deploy no matches for kind scaled object. Okay. Again, let's debug it. kubectl API resources grep -e scaled jobs. I don't have scaled scaled objects. It's scary that I don't have scaled object. Cool, I have a problem again. So let's install Kera again. Maybe I misconfigured it. Install Kera, okay. Delete, uninstall. Every time when I do the demo, I have another problem. Uninstall Kera. Let's uninstall it. Okay, Kubernetes Kera. So let's uninstall it. Again, uninstalled. So let's go to Kera sites. Uninstall. Do I have any uninstallation script in here? Extra enable Kera, git clone. Rename and remove Kera control resource uninstalled Kera operator. Okay, to uninstall Kera operator. Create Kera controller. Okay, I uninstalled it. Okay, seems good. So let's reinstall it. I'm trying so many things on this cluster, so if I have a problem, I sometimes don't solve it. Yes, that one. So let's go to kubectl again. kubectl API resources rep-e scale. Okay, perfect. I have the scaled object in here. So kubectl get pods. Kera is running, perfect. Kubernetes AZ scaling. Okay, kubectl get pods. Let's say that. I don't have any object in here because Kera is working on that object. I mean the deployment. So it sees that there's no need to maintain an instance of an object. I mean instance of an object because it's an event. So it basically make the count to 0. Why? Because I don't have any message in the order bus. I mean the service bus. The message size is 0. So what if? But first of all, I should look the logs of the Kera. kubectl get post-a -n Kera. kubectl get no logs -n Kera. Get the operator if we have an error or not. Perfect. There's no error in here. So what I'm going to do is watch kgpo. So I will add some message to service bots in here. And order bus, service bus explorer, content type, text plain, data 1, data 2, data 3, data 4, data 5, data 6. So let's say that. Let's wait for some time to scale the objects. So right now, I have 6 messages. If we are lucky enough. Controller scale object. Okay, let's wait for some time. Okay, because I don't have any scaled objects. So kubectl apply -f because I didn't deploy auto scaling objects. Auto scaling objects. Exactly. Right now it is created. It is consumed, so I can understand it from here because the updated scale target objects replica count, new replica count 1. Kera is scaled that object. And right now, it will wait for some time to destroy the pods. And after that, if I add some message to queue, it will again rescale the object. So let's wait for some time. Watch KGPO. So let's wait for, it will take 5 minutes to scale down. And I can do that way. Let's add some message to here. Send. No message because it's consuming. Let me kill this pod. DTR scale deployment. We'll try. Dash replicas. Equals to 0. KGPO. Okay. Let's wait. Let's wait. Click. If the API server is not responding, you can use this Y9 comment so you can understand that Y is stuck. So basically, it's request my API server, but the API server is not responding me. Sometimes from the internet, it can be happen. Okay. No, the API server is not responding. Ooh. Watch HPO again. Please don't do that. Okay, cool. KGPO, watch KGPO. Okay, I don't have any replicas in here, but let's add some message to here again. Send another A in here. Let's add another in here. So let's see that the object will be scaled. Let's wait. I think I broke Kera. Yes. So let's look at the logs, Kera. So basically it grabs the message size from the service bus and it makes a calculation, and then depending on that calculation, it creates a pod in here. So if I insert more data to service bus, you will see that the pods will be scaled, and you will see that the object, if I don't have any data in the service bus, it will be scaled down to 0. That is perfect for actually, the event-based architectures. So the thing is, for example, I have an Azure Functions, and depending on, for example, I want to scale my post depending on the storage account. If somebody puts some pictures in the storage account, so depending on that, I can scale, or I can make whole application to scale down to 0. So Kera is basically for that. The key takeaway is there are 3 objects you should keep in mind. One is trigger authentication, the authentication type to the data source, the secret, which will be used to connect the data source, and scale objects, deployment name, scale object name is not so important. The type of the data source to grab the metrics, and the authentication reference. So depending on these 3 parameters, you can scale your pods. So I think that's, for my side, that's enough. So if you have, for example, let's go to Kera site. If you have these data sources, you have Prometheus, basically. So depending on any metric, depending on any metric, you can scale. You can scale any pod, any deployment on Kubernetes. And basically, instead of, for myself, while working with our clients, instead of Prometheus, I'm trying to deploy Kera for that, because I'm using Prometheus for monitoring, using for Kera scaling. So it is very easy to implement. It is very easy to deploy, and it is very easy to maintain. That is the reason. So it's not, we don't need to write complex queries like PromQL compared to, PromQL easy, but Kera, these objects are very easy. So instead of writing PromQL query, I'm just setting that message count should be 5 per pod. That's it. Depending on that, I'm scaling these objects. So today, I think for myself, I'm okay with that. Thank you very much for listening to us.
Thank you very much, Pamir.
I should find you. Okay. Stop my screen and open my webcam. Yes.
Okay. Do we have any questions from the audience? And while we are waiting, I have a question for you. What about the alternatives? If I don't want to use KEDA.
Okay. The alternative one is the Prometheus adapter for that. We discussed about it on previous week. The other how can I say that? The other option is use Zalando's horizontal pod autoscaler for that, external metric scaler for that. Zalando, is a retail company, and they have a couple of projects on Kubernetes, and Zalando's metrics scaler is another option for that. There are a couple of scalers depending on the companies. And I think I haven't used, but I think Datadog has, but I don't know. I have just read it, but basically on production, I used Kera and Prometheus adapter and tried Zalando's one.
Okay, thank you. And I think it is my turn for the next episode. And let's make a challenge. And please send your requests on Twitter and help me to choose the topic. Any Azure related stuff will be much appreciated, by the way. And if you don't date, Pamir will. And I think he may be brutal. So please help me.
By the way, I'm really doing the demos in hands-on. The thing is, while I'm getting the errors, I want you to see the errors while you're deploying. I don't want to see the perfect, happy path of these installations and implementations. I want you to see the errors that we are facing on the customer or while we are deploying on production. So that's why we are getting the error, and instead of dealing with the happy path, we are installing the error. We are dealing the errors in front of you. So basically, by this way, you can understand, and if you have this kind of errors, you can see the error, and depending on our errors, you can fix your errors. That is the reason I'm dealing with the errors. I don't want to see any happy path, because on the client I haven't seen any happy path.
Did you prepare that errors?
Actually, if I'm preparing, for example, we have labs, and one of the labs, I prepared one of the labs. There are 20 labs in there, basic section. On every basic section, there are a couple of errors. While we are, for example, in the deliveries, we are saying to our clients that in this labs you will get these errors, and you will have this errors, and you should fix it. So basically, we are saying that on the lab-based environments, we are purposely creating the errors.
Okay, that's great.
Most of the time on the YouTube videos, the reason is I watch them, I listen to, the Pluto side, Udemy, people are sharing their experiences with the Happy Path, but on the production, the thing is we have lots of errors and we don't know how to fix it. So instead of dealing with the GitHub issues, so if you have this kind of error, maybe it will be on your mind. So maybe you can see it, and maybe I can help you. That's it. That is the reason.
Okay. Pamir, thank you very much.
You're welcome.
Hope you have a new topic for me for the next
I
episode.
have lots of.
Okay, thank you.
Okay, have a good day. Thank you very much for your time.
Thank you
have
very
a
much.
good day.
See
Bye-bye.
you. Cheers.